need to be able to apply the exponent laws shown here. If you multiply two things with the same base, you add the exponents. If you divide two things with the same base, you subtract the exponents. If you raise a power to a power, you multiply the exponents together. And anything raised to the power of 0 is just 1. So let's take a look at an example. If we have y to the 8 times y to the minus 2, what we can do is use the first law up here. We have the same base, they both have a base of y, so we have 8 plus negative 2. So 8 minus 2 is just 6. Right, another example. 2 times x times y squared times 3 times x to the minus 1 times y to the 0. So probably a good idea just to group the numbers together. Do it that way. Group the x's together, so x to the 1 and x to the minus 1 times x to the minus 1 and y squared times y to the 0. So 2 times 3 gives us 6. X to the 1 times x to the minus 1 is x to the 1 minus 1. Okay, we use this rule up here. And then y to the 2 times y to the 0 is y to the 2 plus 0. So this becomes x to the 0. So 1 minus 1 is 0. And this becomes y squared. So finally we have 6y squared for this one. Alright, another example. If we have negative 3 times x times y to the 4th, all raised to the power of 2, we need to use this rule right here. So what we need to do is distribute this 2 into each of these terms inside the bracket. So negative 3 raised to the power of 2 times x raised to the power of 2 times y to the 4th raised to the power of 2. So negative 3 squared is the same as negative 3 times negative 3, which is 9. X squared just stays the same. And y to the 4th squared is the same as y to the 8. So that's the final answer. So one more example here. 5x cubed divided by 20x raised to the power of 1/2. So it's a good idea to just simplify this stuff inside the bracket first. So we can simplify 5 over 20 is 1 over 4. And x cubed divided by x is the same as x to the 3 minus 1. So that just becomes x squared. And then this is still raised to the power of 1/2. So even though it's a fraction out here, the same rule applies here. So we distribute this 1/2 into each of the terms inside the bracket, and we just carry on from there. So 1/4 to the 1/2 times x squared to the 1/2. So 1/4 to the 1/2 times, and then 2 times 1/2 is the same as 2 divided by 2, which is just 1. So x to the 1. And further along we'll see that 1/4 to the 1/2 is the same as 1 over square root 4, which is the same as 1 over 2. So we can write this as x over 2. So that's the final answer for this last example. You need to be able to apply these two rules that aren't given on your formula sheet in order to turn negative exponents into positive ones. If you have a number with a negative exponent upstairs, you can move it downstairs, but you have to switch the sign on just the exponent. Similarly, if you have a number with a negative exponent downstairs, you can move it upstairs, but you also have to change the sign on just the exponent. So let's take a look at an example. Y to the minus 2 times y to the 5 over 2. So when we're multiplying two things with the same bases, we add the exponents. So minus 2 plus 5 over 2. So you can do this the old-fashioned way. You can get each of these to be over the same denominator, add across the top, and then simplify. If you prefer, you can also do this in your calculator though. Negative 2 plus 5 over 2 will give you 0.5. And if you can't see that that's a half, your calculator can convert this into a fraction for you automatically. So this turns out to be y to the 1/2. Another example, x to the 1/3 times y to the 4/5 raised to the 0 times x to the 1/3 raised to the 6th power. So this first term, you need to distribute the 0 to each of these exponents. So 1/3 times 0 is just 0. 4/5 times 0 is just 0. And then 1/3 times 6 is the same as 6 divided by 3. So recall each of these, anything raised to the power of 0 is 1. And then 6 divided by 3 is 2. So we're just left with x squared. Another example, 3x to the minus 2 divided by negative 2y squared, all raised to the minus 2 as well. So one way you can go about doing this is sort of distribute this exponent into each of the terms here and here and here and here. So 3 to the minus 2 x to the minus 2 over negative 2 to the minus 2 y squared to the minus 2. Now we have a bunch of negative exponents kicking around, so we need to change these into positive exponents. So what we can do with this 3, if it's upstairs with a negative exponent, we can move it downstairs and switch the sign on the exponent. And with this negative 2 raised to the minus 2, we can move this upstairs and change the sign of the exponent. So this will become negative 2. So the number still stays the same, but we flip the sign on the exponent. Same for x to the minus 2. We can move it downstairs and change the sign of the exponent. And y to the 2 raised to the minus 2 can become y squared to the positive 2. So in the end we end up with, so negative 2 squared is 4, y squared squared is y to the 4th, so 2 times 2 gives us 4. 3 squared is 9, and x squared stays the same. One last example here, 6mn cubed divided by 4m squared n. So might be a good idea to simplify the things underneath within the bracket. You can simplify 6 over 4 to be 3 over 2. And then m divided by m squared is the same as m to the 1 minus 2. So this is m to the minus 1. And then n cubed divided by n is the same as n to the 3 minus 1. So n squared. And this is all squared. So 3/2 will have to have the squared applied there. So we'll have to distribute that there, to that exponent, and also to that exponent. So 3 squared turns out to be 9, 2 squared is 4, m to the minus 1, so minus 1 times 2 is minus 2, and squared is 2 times 2, 4. So now this has a negative exponent, this m term, so we want to move this downstairs to give it a positive exponent. So 9 over 4 will stay the same, n to the 4th will stay upstairs, and then we'll move the m to the minus 2 downstairs and then just change the sign of the exponent.